So here's my mathematical solution, I think, to solving Matt Parker's Scrabble problem. I think this is a bit easier than what you showed, and hopefully, as I explain it, you can follow it. It's like your solution, not absolutely foolproof. There are ways that people can cheat, but it does give some level of anonymity and does hide what your letters are. So what I have done is create a set of pieces. Each piece here has a letter on it and it has a prime number on it, and I've picked a different prime number for each letter. At the moment I'm just using the first 10 letters, so we have A to J, and I first picked the first 10 odd prime numbers. The only reason I picked odd is to make it more obvious what is going on. To hide what is going on, because it would be obvious otherwise. So first thing we are going to do is we are going to put each of these pieces in one of the positions. Now you would do this as a random shuffle. You can do this for yourself. You don't need to agree it with your partner. You are going to randomly shuffle your letters and put them down. And just meant to say as well, these prime numbers that are attached to each letter would be decided with your playing partner in advance. So I'm going to shuffle these. I'm going to put them down. So I'm going to put that one there. We're going to have this here. We're going to have that there. So I'm just shuffling my letters. Now I've made mine a wee bit thin so you can actually see through on the camera, but if you made them up card, you wouldn't have that problem. So we're going to put J down. So this would be a totally random shuffle that I would do. I've set this up in advance just so I know what letters I'm going to get, and I can pre-calculate all the numbers. So there are my letters set out. Now at this point, your opponent is going to actually pick which letters you get when you draw from the bag. So you're going to draw from this set, but your opponent is going to generate some random numbers, but they don't know what these letters are, so they don't know what order of what letters they're giving you. They're going to select a random number between 1 and 10. You're then going to select those letters. So for example, they might select 5, at which point you would take 5. You secretly would look at it and now know that you've got a J. Now this is where these primes come in. So before the game, you agreed which prime numbers go with which letters. Shuffling them up makes it harder to remember what's going on. Also before the game, you are going to generate a massive big number here. That is generated by taking the prime associated with each letter. So 23 is associated with, I'll put it on the screen. 23 is associated with A, and that happened 9 times, so we've done 23 to the 9, times 13 is the prime associated with B, and that happens twice, so we squared it. C, 7 is our associated prime, and we've squared it because it's times 2 there. There's 2 of them in the game. D, 3 is my associated prime, and we've got 4 of them, so put it to power 4. So we generated this number. Now it's massive, but roughly speaking, if you do it with all 26 letters of the alphabet and all the times they appear, we're talking about 100 to 150-ish digits in this number, absolute max. It does depend a bit which primes end up with things like A. So if you pick something a bit bigger, like 107, ended up with A, you're going to end up with a bit bigger number here. So this number is generated before the game begins. Now, every time you choose a letter, you're going to refer back to this number. So using a bit of an online calculator, so maybe Wolfram Alpha, generate this number. Every time you pick a letter secretly, you are going to check this number mod that prime. If the remainder is 0, you keep the letter. If the remainder is not 0, you score out the back of the letter and you pick something different, because that means that letter is run out in the bag. This is like our bag. This keeps tally of everything that's going on, and I'll explain how it does that in a second. So you've got all your letters. Your opponent is picking random numbers. So the first one they pick for you, say it's 5. So you take 5, you store it to one side, you've checked it, you do your massive number mod your 31 because that's for J. It comes out with the remainder 0, so you keep it. You do exactly the same, so maybe their next random number that they pick is 4. You mod your massive number with 23, and you check it, and that's absolutely fine. Bear in mind they could pick the same random number twice. That is absolutely fine. That doesn't cause any problems. They give you another random number, say 9. So you're going to mod your massive number with 5. Comes out remainder 0, so you keep it. And finally, maybe they pick 1. You mod your massive number with 19. You get a remainder 0. And that is absolutely fine. So you've kept all your ones this time. But that is going to vary in the future. I'll show you an example where where we don't keep them all. So you've checked them all. Next thing you're going to do, now you've got your digits, your letters for this round, you're going to take your very big number here and you're going to divide it by 19, by 5, by 23, and by 31. So you're going to divide it by all of these, and that's absolutely fine. So you're going to divide by all of those, and you get an answer. Now, I've actually worked this out in advance, just so we don't need to work it out on camera. But that's like dividing by 67,735 altogether, and this is our answer. So we're now down to a 50-digit number. And you send that 50-digit number to your opponent. That 50-digit number is keeping track of what letters are left in the bag. Now, next turn comes around. When it is your next turn, you are going to shuffle your letters. So we're going to move these round, and we're going to do so randomly. So our opponent doesn't know how we're moving them. We're just keeping track of them ourselves. We're just moving them around. We are setting it up for the next round. So I'm just randomly shuffling these so that my opponent can't figure out. And you could do this off camera. Your opponent doesn't actually need to see this step. The key thing is they don't know what letters you're picking, even though they're generating the random number. So we've got some kind of setup like that, and we're off. So we're now looking at this massive number, and every time they call a random number out to us and we pick a letter, then we check it. So, for example, with that big number there, maybe they pick 5, which is an H, and you mod that big number there with 19, and you find it's got remainder 0, so you keep it. Now, the next one they pick, they happen to choose a random number that they send you as 2. You pick that. Now, when you mod that massive number there by 31, it comes out remainder 22. That tells us there are no more J's left in the bag. And that's because we picked the J last time, we divided through by 31, and it's no longer a factor. And this is where primes come in. So we can put a big X on the back of that one. We're never going to end up with that letter again. The opponent doesn't need to know which letter it is we've run out of, but it stays in our set, but we put an X on the back so that we don't need to pick that one ever again. And we don't need to check the modding of that one ever again either. Whole process continues. You're noting down all the time what letters you're getting and shuffling in between rounds. And every time you do a round, you're dividing through by all the numbers that you have got on the letters you've got. So here we'd be dividing this number here by 19, and that would update that number and leave us with our other factors. So hopefully that shows you the method, and if you're doing it backwards and forwards between the two of you, shuffling every time, you're never going to know what numbers or what letters the other person has got. If you don't shuffle until the beginning of your turn, it also allows you to exchange letters. So long as you know where the letters are, you can put your letters back and it doesn't affect this process. You just times up. So if you do an exchange, you times up the number and then send it back to your opponent. Times it by all those prime numbers that you're putting back. The only possible weakness is if your opponent is sitting there working out what's been divided by and factoring that number every time, they could technically work out what letters you have chosen, but that does rely on quite a lot of effort and a little bit of honesty. Hopefully this gives you a good solution and something interesting to think about that is really mathematical, but also solves the Scrabble selection of letters question.